that means. All right, so everybody remembers how, well, first of all, I'm not an artist. Okay, Iona, can you see me over here on this side of the board? Not really? Okay. All right, so if you guys remember how okay, so everybody remembers my human body, all right, and we've got our brain, all right, got our spinal cord, okay. In the spinal cord, we talked about there being the white matter and the gray matter, okay. The gray matter was like the little butterfly, okay, and then the white matter had our tracts, T-R-A-C-T's, okay, where we had to take information up the spinal cord and we had to send responses down the spinal cord. Okay, so now if I have this posterior root, all right, that's full of those nerve cell bodies, those neurosomas, okay, if you remember, sensory information needs to come in, all right, and it comes in on that posterior side, all right. So if the sensory information comes in and it gets to this dorsal root ganglion, if this is where my nerve cell bodies are, for that axon, that fiber, and if you guys remember, okay, let me kind of draw nerve cell body with my little dendrites, okay, that nerve cell body is going to be in that ganglion. And then it will synapse with, I know, my art's bad, okay, another nerve cell body that will now travel the spinal cord. So therefore, information either into or out. Does that make sense?
Does the axon of that one go all the way up to the brain?
Yes, because remember, if we're talking about that information going up, the sensory information brought in, do you happen to remember how many neurons were needed? 3. Because if you remember, we've got something that picks up the information. We bring it into the spinal cord. And do you happen to remember where that third neuron was?
Thalamus.
Remember? Okay, yeah, and thalamus. All right, so it would take it up to that area where it will synapse. What happens to it after that? Just kind of a quick reminder.
It goes to the other area of the brain that it needs to and then back down.
The thalamus will determine what area of the brain it needs to go to. Good job. All right. So that ganglion, rather important, okay, with all those nerve cell bodies. So note, because I keep trying to point out that right now, at this point in time, the activity that we are referring to is going to be activity to my skeletal muscle. That is the only muscle that I am referring to at this point in time. Okay? So, my posterior root ganglion, or i.e. the dorsal root ganglion, because dorsal means to the back, okay, is associated with spinal nerves. What? Because I haven't gotten to the part. There are 3 types of muscle in the body. 1, 2, 3. I got skeletal, I got smooth, I got cardiac. And right now, the only thing I'm talking about, the only thing we're looking at right now is skeleton. Any questions? Did y'all think about your spinal system over the weekend?
No.
Oh, come on. All
Is
right.
it part of skeleton system? The spinal.
We're going to see, because as we think about that spinal nerve that exits the vertebra, as we see it make its way around, it will meet skeletal muscle. So, in the spinal nerves that we have, we've got 31 pairs. Because remember, each side, left and right, okay? So at the level of my cervical vertebra, thoracic, lumbar, we have these nerves exiting. So we have 31 pairs. There are 8 in the cervical region. Wait a minute. How many cervical vertebrae do I have? 7. Why do I have 8 pairs? Because there's a very special, do you guys remember when you were studying the bones? C1 and C2, the atlas and the axis, okay? And remember, it is at the foramen magnum where the spinal cord exits. So there's a very special, well, I guess I can't say special. Okay, we just have exit of nerves. So it makes for 8 rather than 7. We have 12 thoracic because we have 12 vertebrae. We got 5 lumbar because we have 5. We got 5 sacral because there were 5 separate bones. But they fused. Same thing for the coccygeal. We have 1, even though there were 3 parts, but that fused. Okay, at the coccygeal area. So 31 pairs. And they are going to service all areas of the body from basically the neck down. Yeah. Huh. What about my head? Cranium. But just hold on to that thought, okay? So, we've noted that we've got the fork in the road. As that spinal nerve enters the vertebra, it forks. So that we've got the anterior, the posterior. And then, not only does it forks even more to create those rootlets, okay? So, the dorsal or the posterior side, like I keep saying, sensory input, all right? Everything that we're recognizing, whether you know it or not, okay, because that's really cool about the nervous system. It's picking up stuff we're not even aware of. So, sensory information goes in, keep talking about the ganglion and having the nerve cell bodies, and then their rootlets. Anywhere from 6 to 8 will be the rootlets that exist. Anterior is for motor output. What is the response that has been integrated in the area of the body to give us a motor or a effect that has to take place? Once again, 6 to 8 rootlets on that anterior side. That cauda equina, we do see, if any of you took a peek at this last week, the cauda equina that exists serving the lower portion of the body and the lower legs, okay, requires hefty nerves. Those nerves are huge, those nerves are long, and those nerves are numerous. But those nerves do not have to be fine-tuned. They are actually very just work-like, okay? Because their goal, helping us walk. Because technically, we should not walk upright, okay? But we do. The spinal nerves are listed here. Something that I want to point out. Can't remember if I think we sort of mentioned it, where I kind of showed or pointed to where there were these big nerves that look like they kind of come out and they kind of merge a little bit and they create this big, huge area of nerves. This is termed a plexus. A plexus is going to be a huge grouping of something, all right? So whenever you hear that term, you're going to let it make you think of something grouped together for a plexus. We're going to see we have a cervical plexus. As we continue down our spinal cord, we have a brachial plexus. Well, which area of the body do you think that serves? Our arms, okay? As we continue down our spinal cord into our thoracic region, one of the cool things about the nerves in the thoracic region, do you remember when you were talking about muscles? And when you studied the muscles of the ribs, do you happen to remember like their structure of those muscles? Yeah, and they were kind of touched, but at the same time they were in different directions. Because you've got to inhale and exhale, and it allows those muscles to be able to do that and that, and I love the thoracic spinal nerve. We have a lumbar plexus. As we continue down, we're going to find we have a sacral plexus and a coccygeal plexus for serving the lower regions of the body. So when we hear that term plexus, just remember it's going to be a huge grouping of those nerves. They're serving a particular area of the body. Now, these nerves, well, one of the things that as we look at them closely and where they exit the vertebra, they're going to do some interesting branching right as they exit the bones, okay? So, if we look at that, do you guys remember the term ramus from part 1, where it was talking like something to like almost to a point or to an extension on the bones? Okay. Well, what we're going to find on these nerves, we have some rami, a ramus, because remember, even though we're looking at it in terms of serving